Good morning, students. In this session, we'll discuss about another type of illumination engineering, that is a street lighting scheme. Okay. So we'll discuss about the street lighting in this class. So here, street lighting is a there are illumination for the different purposes we have. So one is for street lighting application, industrial lighting, and flood lighting. So these are the main important applications of illumination engineering. So in this session, we'll discuss about the street lighting and its what are the types of lamps used for the street lighting purpose. Okay, so this content of this today's presentation will be need of street lighting, the definitions related to the lighting scheme which is already discussed, and the distribution of light. Okay, so the design factor for the street lighting. So these factors here in this session will be discussing about need of street lighting, then distribution of light, and the design factors for the street lighting. So these will discuss in today's class. Okay, so need, why the street lighting is required. So the need of street lighting, the main purpose of this street lighting is to enable the roads to the users to see actually and easily carriage away and the immediate surrounding in the darkness. So that means in the darkness, so the need of this street lighting is to make the road users to go smoothly. So the majority of these road accidents are caused in the night only. Okay, and the poor lighting in main cause. So poor lighting and during the night, so the majority of the accidents are happening. Okay, that is why so the street lighting is required. So the improved visibility at the nights may, by means of the artificial lighting, will reduces the efforts of the drivers or strain on the drivers. Okay, that will once again reduces the road accidents. Okay, so the driver feels more confident in driving under the proper street lighting. So if you're having a proper lighting, so then the driver can feel easy, can comfortable to ride during the night. So because of these reasons, the street lighting is required, street lighting is necessary. Okay, so with the better lighting, so because of with the better lighting, the speed of the traffic is generally improves, and the traffic flow conditions also improves. So if the street lights are, if you have a proper illumination on the surface, so the speed of traffic is improves. So once again, the traffic conditions is also going to improve here. Okay, so the highway lighting is the particularly more important in the intersections, bridges, okay, and bridge sides, level crossings, in the places where there is a restrictions of traffic movements like schools, hospitals, and etc. So wherever the there is a restrictions for the traffic movements, there the street lighting is required. Okay, on urban roads where the density of populations, okay, density of population is very much high, so when the road lighting has other advantages like feeling of security and the protection. So these are some of the purposes, needs, these are some of the points that will supports the street lighting applications here. Okay, so this, because of this, the need of street lighting is going to be improved. Okay, then factors which affects the visibility. So factors which affect the visibility during the night, what are the factors which are affecting the visibility during the night? So the first is the amount and the distribution of light flux from the lamps. So how much amount and how much light is distributing from the lamp, that's the one factor which will affect the visibility during night. And the size of the object, present, which is also affects. And then brightness of the object, how bright the object is. Okay, and the brightness of the background. So and also the reflecting characteristics of a pavement surfaces, the roads, some of the roads they have some, because of because of the continuous uses, so there is some reflecting paths are produced, reflecting surfaces are produced. So the reflecting characteristics of some of the pavements on the surface, that may also affects the visibility. And also glare on the eyes of the driver. So the glare is nothing but it's a which will also affects the visibility and the time available to see the object. So if you are driving in a car in a night with the street lighting, so the time available to see that particular object is very much less, and that which also affects the your visibility on the surface. So the definitions related to this illuminations is already explained in the previous classes. So now the distribution of light, the output of the point light source will be naturally radiated uniformly from the point with the equal intensity in all the directions. This is so if you're having a light source, so the rate that will emits the radiates the energy uniformly from point with the intensity in all, same intensity in all the directions. That's the one point. So it is once again evident that okay, such light distribution would be insufficient, okay, and uneconomical when the purpose is to direct the light towards the relatively limited area. So if you want so relatively limited area where you have to illuminate, in that case, so this equal distribution, uniform distribution will not be working, such as a pavement streets. So if you want, there is a focused area where you have to illuminate, so the uniform illumination is not required. So you have some focused pavement area where you have to illuminate. So in that cases, so your distribution is inefficient or uneconomical. So uniform distribution is inefficient or uneconomical in those cases. So there are mainly three types of distribution of lights in the street lighting applications. One is a glare, then vertical distribution, and lateral distribution. So these are the three types. So one, glare is nothing but, as I said, so the amount of glare which is present, glare is nothing but it's a discomfort caused to the human pulp of the human eye when it is exposed to the bright light source. So when the human eye which is exposed to the bright light source, the discomfort which is caused to the vision, so that is called as a glare. Glare is nothing but the unusual sensation caused upon the human pulp of human eye, so when it is exposed to the bright source of light or reflections of light, so that is called as a glare. So I think you have experienced this glare so many times while you are riding during the night. Okay, so this amount of glare which is present, which is depends on different factors: brightness of the glare source, how much bright the glare source is, the angle of incidence with respect to the normal line of vision, so how much, at what angle the reflected light will be falling, that's also one thing, and also the area of glare source. So area, whether it's a smooth area, reflecting area, whatever it is, so that will also matters. Then the distance of a glare source from the observer, how much distance that the glare source is present from the observer side. Okay, so these are the some points with respect to glare. Then vertical distribution of light is nothing but vertical distribution of light in street light system follows one of three types. So we have various types. So that is, one is cutoff. So in cutoff system, what happens, the light is reduced as completely as the rapidly possible above 70-degree angle, okay, with the downwards vertical means. That means vertical means the main beam is being usually at the angle. So this system eliminates the glare. So cutoff system is used to eliminate the glares present in the custom cutoff system. That means, so your the light will be incidenting at a 70-degree angle with the downwards in a vertical plane, so which will affects the glare caused is less. So if for example here is your street lighting, so here is an observer, okay, so the 70-degree, so the light is emitting a 70-degree, so which will be reflecting back by the 70-degree only, so that will eliminates a little bit amount of the glare. Okay, next is non-cutoff or high angle beam. So non-cutoff or high angle beam system, here what happens, the peak intensity is about 80-degree and there is a considerable output near the horizontal plane. That means the degree of inclination is 80. Here is a source of light, it's a 80-degree, and here is a observer. Okay, so the degree of inclination is 80-degree in case of non-cutoff region, and semi-cutoff is the non-cutoff. The non-cutoff medium, it's a in between. So semi-cutoff is the direction, the angle of incidence is around 75-degree is the angle of incidence. Then the lateral distribution of light, how this lateral, these are all about a vertical distribution what we discussed. So the lateral distribution is nothing but, so the distribution of light in the horizontal directions is equally important. So not only the distribution of light in a vertical plane is not only important, at the same time the distribution of light in a horizontal plane is also plays a very important role. Okay, it's not at all enough that the pavement alone is lighted from the aesthetic considerations. That means, so there is not at all enough. So if you're having a uniform illuminations and horizontal illumination, nothing, so there should be a proper illuminations from all the angles, that is horizontal distribution, vertical distribution, everything should be there. Okay, so the pedestrian, that means those who are walking on the footpaths, so footways, so and they also need to be adequately lighted. So the need, this purpose of street lighting is not only to serve the roads but also to serve the pedestrians. So it is as well as the driver, I mean vehicles, and at the same time the pedestrians also should get the sufficient amount of illuminations to walk through. Okay, that is why, so you have to consider the lateral distribution, vertical distribution, and the glare. All these 3 points, they should be considered while designing a any lighting scheme for the street lights. Okay, that's the third point. There are three types of horizontal distribution: the symmetrical distribution, the axial distribution, and the non-axial distributions. Okay, so these are design parts, so which are considered while designing the street lighting. So then the design factors of street lighting is, one is considered as a, the various factors are considered to be while designing the street lighting scheme. So one such is a contrast is, so when the brightness of the object is less than that of the background, so you can just so brightness of the object is less than the brightness of the object, then what happens, that is when the object appears darker than the road surface. If the object is darker than the road surface, then you have to consider that situation also while designing this one. The contrast of the light should be chosen in such a way that the every objects on the road should be clearly visible by the observer. Okay, that's the one thing. Okay, next is glare. There should be absence of glare. So another point is very much so important is there should be absence of glare while designing any lighting scheme for the street lights. So by the distributing the influences when the viewing the difficult visual tasks, so that means the glare also should be as minimum as possible. There are two types of glare, so direct and indirect glare, or disability glare or discomfort glare. There are two types of glare, disability and discomfort means, so one such glares will cause the discomfort, and the another type will cause the complete disability of the vision. Okay, these two types of glares are there. You have to keep those 2 points in mind while designing the street lighting applications. So you should be design the street lighting in such a way that the glare should be as minimum as possible. Then another very important thing is, so you have to choose the different which type of lamps for the street lighting applications. So that means there are various lamps are used. So in the street lighting, especially the filament lamps are used, fluorescent lamps, sodium vapor and mercury vapor lamps are used. So in nowadays your mercury vapor lamps are most commonly used for street lighting, sodium vapor lamps, and also now they are replacing with LED lamps also. So LED lamps are used for the street lighting applications. The next is the illuminaries distribution of light. So to have a best utility of a illuminaries or source of light, illuminaries are nothing but source of lights or a lamps. Okay, it is necessary to have the proper distribution of light. So it's necessary to be have a proper distribution of light. So then one and the other thing is, it should be aimed to achieve the following purpose. So the illumination for the street lighting, it should have some of the following factors to be achieved. That means it should cover the pavement between the curbs. So that means the pavement or the roads should be completely covered, the luminaries which illuminates the entire area on the pavements or the road surfaces, and it should make a prominent the traffic signs and other objects on the road. That means it should not affect the traffic signs. So the traffic signs should be prominently visible to the your street lighting should not affect the your traffic light scheme. That means the prominently traffic light should be visible to the observer. Okay, so then it should produce a maximum uniformity of a pavement brightness. What is maximum uniform pavement brightness should be produced? That means pavement is nothing but the road, the uniform brightness should be present at the road surface. Okay, these are some of the points to be considered for this one. Then lateral placement of lighting poles. So once again, now the poles, how the lighting, these are all what are the types of luminaries are required and what are the considerations you have to make. Okay, so while designing a lighting scheme we have discussed. Now the lateral placement of poles. So the poles where you are placing, there are different. In highways you might have observed the poles are in the middle. On either sides there is a road, the poles are at the middle, which will illuminate on both the sides of the roads. Okay, so here the lateral placement of poles is nothing but the lighting poles should be installed very close to the pavement edge. That means pavement edge is nothing but the road or a road edge. So your lighting poles there should be properly installed, very which will be very closer to your pavement edge. Okay, because in that cases what happens, the capacity of the road is decreased and for the free movement of the traffic is obstructed. Okay, so that is why, so the lighting pole should not be installed very close to the pavement edge. So if you are installing it very close to the edge, then what happens, the capacity of the roadway will be decreases, so that will obstruct the movement of the traffic, that will obstruct the movement of the traffic. So the lighting poles should not be installed very close to the pavements. That's a one thing. So IRC has a specified following some of the horizontal clearance for the lighting poles. So you have to follow the those guidelines from the authorities. So the for the roads with the raised cribs, that is as urban roads, what happens, the minimum 0.3 meters and the desirable is 0.6 meters from the edge of the raised cribs. Okay, then for the roads with the without raised cribs or in the rural, what happens, it's 1.5 meters from the edge of the carriageway and subjected to minimum of 0.5 meters from the center line of the carriageway. So these are some of the standard specifications to be followed for the clearance of the lighting poles. Okay, then height and overhang of the mounting. So how much height that your light should be there and other things, there are everything, there is a specification for street lighting. We have to follow those specifications to achieve the required lighting scheme. So the what is the height and how or at what height you have to place the your light, that is also you have to concentrate. Then the glare on the eyes from the mounted lights decreased with the increase in the height. So you can see the glare on the eyes from the mounted lights decreased with the increases in the height. If you increase the height of the lighting pole, so the glares can be reduced. Okay, usually what happens, the mounting heights are ranges from 6 to 10 meters from the pavement, around 6 to 10 meters from the pavement. So the street light lamps are hanged. Okay, so if you have a if you are placing the mountings, if you are placing the illuminaries so bit away from the roads, if it is more away from the road, the glares caused by that particular lamps are less. So because of that, so usual practice for the street lighting fitting is around 6 to 10 meters above the ground level or from the road. So overhang on the street lighting poles would keep the poles away from the preventing the edges. Okay, but still allow the lamp to be held above the cribs or towards the pavement. So the lamps are always towards the pavements and they are placed in the middle. So the poles are placed in the middle and the lamps are always faced towards the your pavements. Okay, then spacing of lighting units is depends upon which type of street lighting. So if it is used for the urban in the cities, so you have a different spacing for the light fittings. So if it is in the highways, state highways, national highways, so once again there is a different parameters to be considered while designing for the street lighting purposes. So the spacing between the lamps on the straight roads, the spacing between the lamps in the straight road, what is around 3 to 5 times the mounting height. So mounting height 3 to 5 times. If your mounting height is 5 meters, so 25 meters is the spacing between each lamp. So 3 to 5 times, so 15 meters or 25 meters. So if you are placing 5 meters height, the lamp illuminaries at 5 meters height from the loads, then the distance between each lamp is around 3 to 5 times. That means around 15 to 25 meters. So that is the thing. And for the sharp or curved roads, the spacing between the lamps is closer for the better visibility. So in the curved roads, the spacing between the lamps will be made closer, so for the better visibility. This is a typical your lighting scheme which is designed for a different purpose is shown here. Okay, so that's about lighting layout. Another important thing is you have to consider is various types of layouts are adopted for the lighting of streets, poles or highways. So that is single side lighting, both side lighting, that is opposite one, then both side lighting, straggled one, then central lighting. So you can see here, this is a single single light, both side lighting, so it's a both side lighting, so it's a single light. See here, three types. Single side lighting, so single side lighting, this is your single side lighting. So both side lighting opposite, that means this is a both side lighting opposite. So both side lighting staggered. Okay, center lighting, this is also called as a center lighting. So these are the different lighting schemes so which are used. Then benefits of this highway lighting. What happens due to the proper street lighting scheme, the police can also do better patrolling during the night, and other jobs, their jobs becomes easier and more manageable. One point. Then in case increase in the business of cities downtowns as during night, which would otherwise have been totally deserted. Okay, the architects and the town planners have found lighting to be major source for the beautifications of their objects. Okay, then due to the good street lighting, there is a considerable reduction in the accident during the night. That's definitely one very good this one, because of the street lighting. Then the illegal actions or antisocial activities on the roads is certainly discouraged by improving the lighting techniques, and it gives the pleasant atmosphere during the night to ride. Okay, so these are some of the benefits of having a street lighting scheme. So in addition to this, there are two techniques are used in the street lighting purpose. One is a diffusion principle. So how much, that means how much light is falling on the road surface will be eliminated back, that is a diffused. So if you're having a, see for example, this is a lamp. Okay, so and this is a black type of black pavement. Okay, and here is an observer. Okay, so whatever the light which is falling on the street will be diffused, and the some amount will be reflected back to the observer. So diffusion principle, that means that is also considered how much how much light is diffused when it is falling from the surface. So based on that also it is considered. Then is specular reflection principle. Specular reflection, so that is also another consider. So see for example, here you have a object. Okay, here is a light, so here is an observer. So that means specular reflection principles are nothing but, so you see here light, so here object, here is an observer. So specular reflection principle, what it says, so the angle of incidence of a light from the light source, so this is the angle of incidence from the light source to the observer will be same as the angle of reflection. That means if it is inclined at a 30-degree angle, it is incidented, so it will be reflected at the 30-degree angle only. So 30-degree angle, that is called as specular reflection. So at what angle it is incident, so if it is at 20 degree, so 20 degree reflection. If it is 30 degree, 30 degree reflection. So how much angle your light is incident, the same angle it will be reflected back, that is called as a specular reflection. See for example, what happens in this case, so the here is object, observer is here, observer is, for example, if the angle of incident is around at 120 degree, so here is object and 120 degree reflection will happen. That means so the observer can see the object from very far away from their place also. Okay, so that these two principles are used while designing the street lighting scheme. So that means angle of incidence should be equal to the angle of reflection, so that the observer can easily see the objects from the long distance. Okay, so these are the two techniques they are used while designing the street lighting scheme. What are those techniques? So one is specular reflection principle, diffusion principle. Diffusion is nothing but how much amount of light will be diffused by the pavements. So considering that also they have to design the street lighting scheme, and also they have to design by using the specular reflection principle. How much incidence, the same amount will be reflected. So by keeping these two in mind, so these two techniques, these two methods are used specular reflection and diffusion principles are used while designing the street lighting schemes. Okay, so another types of lightings is nothing but so industrial lighting and flood lighting. Okay, and the requirements of globe lighting. So another 2-3 concepts are left out, so that I will take up in the next class. Okay, thank you.